Alright, in the last chunk of problems, you just had to know the formula, and then into that, they told you what the slope was, they told you what the y-intercept was. And of course it's important that you understand those, but really on those problems, if you knew the formula, you could just plug and chug, meaning you can plug it in and just chug right along. Now, in writing an equation in slope-intercept form from a graph, the first thing you're going to want to do is always write down the formula. It's your map. So with that map in place, let's talk about how you would find two separate pieces that are missing, which are M and B, from a graph. So just off to the side, I'm going to write, you don't have to, M equals and then B equals. Now, the thing that requires the least amount of work is the y-intercept, and that's later on in the equation, but that's no big deal to jump around like that. And as long as you're clear that this is the y-axis, then from there you can figure out that the intercept is where the y-axis is run into by this line. So here this line is, and when x is 0, that means that y must be 3. And if we really want to kind of map this out clearly, on the left side where I'm showing my work, we know that y is going to stay in place. We don't know what m will be, so I'll put the x in place. And then since the value is 3, that means I'll add 3 and not have to worry about doing plus or minus or just writing subtraction. In this graph, they give you two very clearly defined points that are not just clearly defined by where they run into the grid, but also clearly defined in that they are labeled. And so to set up a rise over run, how much does the y change for the x? Let's show a triangle here where we're going downwards and then turning, so that we can see that the change is actually going to be starting here 1, 2, 3, 4 steps. And then just to be able to reference the previous section, 3 minus a negative 1 would give us 4, so we could calculate it too. So here I am showing the 4 steps going down. Now, whether or not you put a minus here, that's fine. But if you don't, just remember that you're going to have to check it and remember, well, if my line's decreasing, I better make sure it's shown as negative. So that's my rise. That's weird to think. It's rising negative 4, but that's the verbiage that we use, the words that we use. So it's rising 4, and then this is much easier to count. I'm going 1, 2, so I'm going to label this as 2. In the equation, I'll write negative 4 over 2, and if you ended up simplifying this in your head before you even plugged it in, I don't think that's an unreasonable shortcut. I think that's absolutely fine. I'm sure a lot of you are comfortable with this, but I want to talk about a common mistake I see. So if somebody has steps to take from here to there, maybe they want to run into somebody on the right side, you would never begin counting where you're standing. Like, oh, here's 1, 2, 3, 4, 5, 6. That doesn't make any sense, because here you have not moved at all. So it's 1, 2, 3, 4, 5. And I point that out because I see some people start here like it's 1, 2, 3, 4, 5, and that's just totally off. That's not correct, because you're not counting 1, 2, 3, 4, 5 lines. You're counting your steps. So how far do you have to move? So that's why I'm pointing this out, is because I do see some people make that mistake. You can check these. You could actually plug in values. Now, of course, this is probably being a little excessive, but if I plug in 0 for x, I hope we get 3. So if I plug in a 0 here, negative 2 times 0 makes this whole term go away. And then I take 0 and add 3, which means that I would get 3 for y. And so the coordinate 0, 3 checks out. Same deal. Plug in a value of 2. Negative 2 times 2 gives you negative 4. Plus 3 gives you negative 1. So yeah, that also checks out. taking a look at this one, we don't have labeled points. We also don't have closed circles at those points. I don't think anybody would want to try to find a point here or even here. And definitely not in either of those three locations. But if I look at this coordinate, and this coordinate, it seems like it's kind of making life a little bit easier. And of all of the ones to label, I think it's going to make most sense to label this value definitely, because here's 0, -1. That's at least 1 point. And then it's kind of nice to deal with positives, so maybe I'll label the other guy over here as 4, 1. And I totally misspoke there. 4, 0. Probably caught that on me already. Good, if so. So just like in the last problems, y is going to be equal to mx plus b. The directions haven't changed. We're still going to write an equation in slope-intercept form. That's what we're going to be asked to do for this problem. And if I want to count, I can. There's my triangle that I'm setting up. But we know that it's nice to look at the y-intercept first, which gives us -1. And just for the heck of it, I will be a little bit exhaustive on this. So here's y, here's x, and by exhaustive I mean writing plus a -1. You're probably fine jumping into just writing -1, and that's cool, but I'm showing all my steps since these are the notes. And then if I want to know how much it rises, well, it's going up 1 and then over 4. And you can see how counting this is a little bit more smooth because we have 0 values and we're kind of butted up against the x and y axes. So it rises 1 and goes over 4. So you're tempted to want to say that it's a +4, but as you're looking at these slope problems, you know, this would mean you'd go up 4 over 1, which would make it more steep. This goes up 1 over 4. And so that we are clear here, let's go ahead and put m equals rise over run. Now notice I'm not using the delta y over delta x, y2 minus y1 equation. That's just more work. So here's 1/4. This is more about counting. So here I am writing 1/4. This wouldn't be simplified. 1/4 is, but then I'd have to turn plus and minus into just -1. So there we go. And same as before, you should check these, you know. So let's plug in 0. Plugging in 0, this term goes away. I subtract 1, which gives me -1. Check 4. I plug in 4. 1/4 of 4 is 1. And then 1 minus 1 gives me 0. So this checks out. So yeah, all good there. That's it for this video. So this is how you would get equations from graphs, as long as they're linear and kind of approachable. There might be times where you have to kind of backtrack or whatever, or maybe count up and over to make your work easier. But be flexible as you graph these and come back with questions if any of them seem different.